Hello, new, aspiring, and seasoned Crestron programmers alike. Today we have a very interesting video for you. We're going to be putting together a simple, pun intended, home theater system. Throughout the duration of the video, you're going to see pop-ups appear, and these are links to videos referencing the symbols that we're going to be using in our program. If you feel pretty confident about the symbol as we address it, go ahead and skip clicking on those cards, but if you need a bit of a refresher, they are there for your convenience. Alright, so before we get started doing the actual programming and configuration, let's take a look at our wiring diagram. Okay, so it's a little difficult to tell what the goals of the system are just by looking at the wires, so here's what we're trying to do. We're trying to take video from the cable box and the Blu-ray player and put it on the TV, and we're going to take audio from those same two devices and pass it to some external speakers. And what our processor is going to be doing is taking input from our X panel over the network, telling our switcher which of these sources to view on the TV, and then passing all of that data forwards. In addition, we're also going to have some volume controls over these speakers. We're going to be able to turn the TV on and off, and we're going to have a little bit of extra control over the switcher. So it's not a very complicated system, it's actually pretty small. So let's go ahead and add these devices into our Crestron system. The first thing though that we have to do is we have to give the system a controller. From the wiring diagram, we're going to be using an RMC3, so I'll just expand the control systems folder and then scroll down until I find it, and then I'll click and drag the RMC3 over to the folder right here. Now the way that you configure the peripheral devices is by looking at what ports on the actual physical devices things are connected to. So Ethernet devices will fall under the Ethernet slot on the RMC3, CrestNet devices will fall under the CrestNet slot, IR devices will fall under IR, and so on. Let's do the Ethernet devices first. So if we expand the Ethernet slot, we're going to add an X panel to IPID03. This is going to be the controller for our system. And we can either scroll down through this to find an X panel, or you can hit the X button on your keyboard, select it, and then hit OK, and an X panel appears at IPID03. The next item we're going to add is the DMTX201, and we're going to put that at ID10. So to add that, we'll right-click, Add Item, and we're going to look for it by the model name, so DM-TX-201-C. There that is, we'll hit OK, add that there, and it pops up under ID 10. The last Ethernet item we're going to add is the DMRMC. It's kind of an unfortunate name because it shares it with the controller, but that's just fine, we'll work with it. So we're looking for a DM-RMC-200-C, which is right there. So we'll hit OK, and that appears under ID 11. So the IDs that I've chosen here are completely arbitrary. You can choose any IDs that you want. So that's it for the Ethernet devices, so I'll go ahead and close that. Now from our wiring diagram, we know that we're going to be controlling an Extron switcher from the COM port of the RMC3. So what we're going to do is verify that the COM port on the RMC3 is configured correctly to communicate with the Extron switcher. So like I did, I just right-clicked and went to configure, and under the serial settings tab that pops up, we want to make sure that all of these settings are correct for communication with our device. And luckily this happens to be a really common configuration with most third-party devices, so this looks good. We're just going to hit OK. Alright, and the next things that we're going to add are the IR devices. So we had our cable box and our Blu-ray player, and those are going to go under the IR slot. And when we expand it, we notice that these are empty. And you're probably thinking, oh, well, I can just right-click this and add an item and it'll show me a list of things, but surprise, it doesn't. We have to actually add these manually. So what we're going to do is we're going to scroll up to the top here, close the control systems folder, and expand user devices. And then under that, we're going to expand the Crestron database, and we're going to sort these things by manufacturer. In port 1, we're going to have our Blu-ray player, and it's going to be a Panasonic Blu-ray player. So we're going to scroll down here until we find Panasonic. And interestingly enough, Blu-ray players are listed under DVD, don't ask me why. But our model number is the DMP-BDT300, so we'll click and drag that bad boy over to IR port 1. And that takes care of our Blu-ray player. The last IR device is our cable box, which is a Cisco make, so we'll go ahead and close Panasonic and scroll up till we find Cisco. And expand that. And under TV tuners, we only have one option. We're going to be using the IPN330HD. In real life, you'll probably end up controlling devices that don't really have an IR file inside of the device library. Usually you can get away with using something that has a similar model, at least that's made by the same manufacturer, Most of the time there's some overlap in the IR protocol. Okay, so that takes care of the IR stuff. We'll go ahead and close the Cisco folder and de-expand the user devices folder. The last thing that we need to do is make sure that the DM RMC is configured to communicate with the TV, because the TV is connected directly to the COM port of the RMC. So I just expanded the Ethernet slot under the RMC3, and then if you look, I can expand the DM RMC, and it gives me a list of all of the slots available on that device. So under the DM RMC's COM1, I'm just going to right-click it, head over to Configure, hit the Serial Settings tab, and make sure that these are the correct settings to communicate with our TV. And again, these settings are perfect, so we don't need to make any changes, so I'm just going to hit OK. And that's all of the devices added. Our system is configured. All we need to do now is the programming part. A good place to start in most cases is with power. In our very limited system, we're only going to be controlling the TV's power state, so we're going to make it as easy as possible. So first I'm going to add a new subfolder under the logic folder called power by typing sub:/power. And then we need to know where the power button is going to come from on the X panel. So let's take a look at the panel we've already created. The power button has a join of 1. So that means that press 1 is going to be input from the X panel, and feedback is going to be what we tell the panel the state of the button is. So I said we're going to make the power simple, and what I meant by that is we're just going to use a toggle. So we're going to capture our input from the X panel, and we're going to call that signal power. We're going to use that to drive the clock input of our toggle, and then the output of the toggle is going to tell the X panel what state the button should be in. So there we go, that's it, that's all we need for the button state, but we still need to actually send commands to the TV. But let's think through this for a second. So once we turn on the TV, we have to tell it which input to switch to, and then since we're using external microphones, we probably want to mute the audio on the TV, otherwise, it sounds weird. So instead of driving a power on command just with the output from the toggle, we're going to use a stepper, and that's going to trigger a bunch of different things to happen when the power turns on the TV. So once the stepper is triggered, we're going to wait 0 seconds to send the power on command. And the TV takes about 6 seconds to warm up, so we're going to have a 6-second delay between the source selection. And then we're going to wait a ½ second to send the mute command. So now to actually send the commands, we're going to use an SIO symbol. And let me clean this up here. I don't need all of these symbols open at the same time. So let me expand the number of inputs on the SIO by hitting Alt+, and then we're just going to take the power on, source selection, and then the mute pulses and drag those over to the SIO. So we've done our due diligence for the system, and we already know beforehand the commands that we need to send to make these things happen. But we still need to actually pass these to the COM port of the RMC. So we're going to take the output of the SIO, we're going to give it a name, and then we're going to expand the RMC, open up the COM port, and we're going to click and drag the TV transmit signal over to the TX line of the RMC's COM port. Actually, I made a mistake. This should be power on. The stepper should be triggered by the output of the toggle. That was my mistake. Alright, so now when the stepper is triggered by the toggle output going high, we send all of these commands, power on, source select, mute. They get encoded into the TV transmit signal, and that signal is passed to the COM port of the RMC, which in turn goes to the TV. Awesome. So we've got startup configured. All we need to do is tell the TV how to turn off. So for the sake of continuity, we're going to use another stepper. And what are we going to use to drive this? Well, we're going to use the opposite of the power on signal. And we're not going to wait any time to send the power off command, but we are going to make the power off command last for another 6 seconds, because that's about how long it takes for the TV to actually turn off. And we could go through the whole rigmarole of adding a new SIO and then putting this in it, or we could just use the existing SIO, click and drag the TV power off over here, and then type in our power off command, which excitingly enough is the same as power on, except the 01 turns into a 00. So we're doing pretty well so far, but we've overlooked one small thing. With our current setup, the user can shotgun that power button on the X panel, so they can go at it rapid fire, something like da-da-da-da-da-da-da-da-da-da-da. And that's no good, because that can really mess with your equipment. It can make the system behave in weird ways. So what we're going to do is limit how quickly the user can change the TV's power state. And we're going to do that by using the busy outputs of our steppers, and then gating the clock input of the toggle. So while the TV is turning on, we're going to give this a busy signal of TV powering on, and when it's turning off, TV powering off. Very creative. And then feeding into our toggle, we're going to have the output of a buffer. We're going to be super creative. We're going to use the same output from the X panel to drive the buffer, and we're going to use a similar signal name on the output of the buffer. We're just going to append buff at the end of it. So that's looking pretty good, but we still need to gate this enable line. So we're going to take the outputs of our steppers and feed them into a NOR symbol. Actually, let's clean this up a little bit. We need our steppers and our NOR. So when neither the TV is powering off nor when it is powering on, the user will be able to press the power button. So we're going to call the output of the NOR TV ready. And then we're going to use this to drive the enable line of our buffer. All right, so this is looking pretty good so far. Let's save, compile, and load to our program and see how it looks. So when I push the power button, we see that the text changes from power off to power on, and then it stays bright, indicating that the power is turning on. So it's been probably about 6 seconds now. Let me push it again. We see that the power state goes to power off, and it won't change to power on until the stepper timer has expired. So now we're to the point where we actually control the TV's power state. Let's move on now to source selection. The only two sources that the user is going to be able to select are the cable and Blu-ray boxes that are controlled by IR. And the buttons actually connected to those sources use joins 5 and 6. So let's open up our X panel. And then give these signals some names. Now, if we wanted, we could literally just tie these two signals to an SIO, pass the commands to the switcher, and then just make those sources appear on the TV without any feedback on the X panel. But we do want feedback on the X panel. In fact, what we want to happen is when the cable box is selected, we want the cable box controls to appear here, and when the Blu-ray is selected, we want the Blu-ray controls to appear. So when one input is selected, we want the other to be deselected, which means that our situation is perfect for the use of an interlock. So what I'm going to do is just add a new folder under the logic folder by typing sub:/sources, and then we'll add our interlock. And then we'll drive the inputs of our interlock with the cable box and Blu-ray inputs. And now the outputs of the interlock, those are going to provide our visual feedback on the X panel. So what we're going to do is just copy the same signal names, but we're going to change them slightly. And then we'll just take our feedback and click and drag those to the respective joins for our source selection buttons. Alright, so we've selected our sources. Now we need to actually send the commands to the switcher, just like we did for the TV. So as you can imagine, we're going to add an SIO. I can get rid of the X panel now because I don't really need it. And we're going to use the outputs of the interlock to also drive the inputs of the SIO. And the switcher that we're using literally just has 2 inputs and 1 output. So the source selection commands are really simple. It's just the number of the input followed by an exclamation point. So now to actually relay these commands, we need to connect the TX line of the SIO over to the output of the RMC3. So now that that's connected, our commands will be sent directly to the Crestron switcher. But we still have one more small thing that we need to do. If we take a look back at our panel that we created, we have an indirect text join on the top right here, and what this is supposed to do is actually display the name of the source that we currently have selected. And this little black one here tells us that we're going to be using serial join 1 for that indirect text. So the way that we're going to get the letters up there is we're going to add an SIO into our sources folder. And this one, instead of relaying commands, is just going to relay the names of the sources. So the first one is going to be cable box, and the second one is going to be Blu-ray. And we can still drive them both with the outputs from our interlock, so let's go ahead and do that. And now our output is going to be going to our X panel. And the serial join that we're supposed to be using is 1, so we'll just click and drag this over to text output 1. Alright, so when either of these sources is selected, we should see the text labeling that source appear on our X panel. Alright, so let's compile and then make sure that everything's working the way that we want it to. Alright, so first off, we notice that power on is still working the exact way we need it to, and when we press the cable button, we see the cable box text show up in the indirect text join, and then our controls for the actual cable box appear below. And then similar thing happens when we use the Blu-ray. When the Blu-ray is selected, Blu-ray text appears here, and then our little submenu for the Blu-ray player controls appear down at the bottom. But notice that turning the TV on and off has no effect on which source is selected. And that could be okay, but honestly it feels a little bit unpolished. So what we can do is we can change the program so that when the TV is turned off, the source selection route is cleared. So both of the cable and the Blu-ray buttons will be deselected. And then set the switcher to blank. So let's revisit our program here and make those changes. Alright, let me clear up this workspace. So what we're going to do is drive the interlocks clear line with the TV power off signal. So if I look at our TV power off stepper, I can use this signal to clear the selected input shown on the X panel. But this literally just clears the selection shown on the panel. We actually want to send a command to the switcher to tell it to send nothing to the TV. So we're going to open up the SIO that contains the TV commands, we're going to add one more input, and then we're going to use the same TV power off command to send a blank command to our Crestron switcher. And the blank command just happens to be 0 exclamation mark, which you probably could have guessed. And we still have one more thing left to do. When no source is selected, that should be reflected in the indirect text on the upper right. So we're going to expand the selected source text SIO. We're going to use the same signal, and we're going to make sure that the selected source says blank, or none, or whatever feels more comfortable. So let's compile this and make sure that everything is working correctly. So the first thing we notice is that the indirect text says blank, which is good because neither of our sources are selected. So let's turn on our system. We'll select the cable box. We see that the text changes, which is excellent. Now we'll move over to the Blu-ray, and the text changes here, so that's also really good. So when we turn the system off, the text changes to blank, our selection clears for the source, and now nothing should be displayed on the TV. This is all going really well so far, and the next thing that we're going to do is super easy. We're just going to be adding control for the IR devices. Controlling IR devices is really easy because there's literally no feedback from them going into the system. All that you have to do is know the joins for the buttons, and then you can copy and paste those over to your IR drivers. I'm going to do the arrow buttons on the cable box, just for sake of demonstration, but the rest I'm going to leave for you to do. Alright, so our directional arrows start at join 60, which means that in our simple program, on the X panel, I'm going to have to scroll down until I get to join number 60. I don't have enough joins on my X panel right now, but I can add more by hitting Alt+, and that gives me a ton more that I can scroll through, and I'm going to need just a few more. So there we go. Hit Alt+ to give you more joins on your X panel. So join 60 was the up arrow, 61 was the down, 62 was left, and 63 was right. So now all I have to do is expand the IR driver under our RMC3, open up the cable box device. I'm going to stack the X panel and the IR device side by side, and then it's just up to clicking and dragging these direction arrows over to the IR device. For the sake of saving time, I'm going to skip showing you the copying of all of these. They will be in the source project if you download it. Don't forget to copy the IR commands from the press inputs over to the feedbacks. This will actually make the buttons on the X panel look like they're responding to your button presses, which is good. And now we're going to move on to the very last item in our programming to-do list, the volume controls. Down at the bottom of our panel, we have some pretty standard volume controls. We've got up, down, mute, 2 buttons to set the volume to 25 and 50% respectively, And then at the very end, we've got this slider that the user can click to change the volume level to whatever they want. So as far as controlling the volume goes, let's take care of the slider output first. We see from the flashing that it's connected to analog join number 1, so we're going to open up the X panel, and then name the output analog activity 1 as volume level. And we have to take this output and connect it back to the same signal's feedback, otherwise the user won't be able to see what's going on. Now to actually change the volume level on the speakers that we have, we're going to open up the RMC, because that's what the speakers are connected to, and we're going to click and drag our volume level over to the DAC out volume on the RMC. That takes care of the slider. Let's move on to the up and down buttons. From looking at the X panel, we see that the up arrow is join number 7, and the down arrow is join number 8. So we'll navigate back over to the X panel, and we're going to look at joins 7 and 8, and we're going to call them volume up and volume down, respectively. And these two aren't going to take any feedback from anything special, so we're just going to click and drag these over to their feedbacks. Now to actually control the volume level with these buttons, we're going to add an analog ramp. But before we do that, I'm going to add a subfolder to the logic folder by typing in sub:/volume, and now I'm going to add the ramp. We don't need the RMC anymore, so I'll close that. The volume up control is going to go to the up input on the analog ramp, and the volume down input is going to go to down. We're going to use a ramp time of 3 seconds, and since this analog ramp is going to be controlling the same volume level as the slider, we're going to jam those two signals together. And the next thing we're going to do is actually plug in the mute button for the ramp. So if we go back to the panel, we see that the mute button has a join of 9. So on our X panel, we'll just add volume mute to press 9. And we're actually going to use a toggle to drive this input of the ramp. So under the volume folder, I'm going to add a toggle. And we're going to use the volume mute signal from the X panel to drive the clock input of the toggle. And the toggle's output is going to go back to our ramp. And we still have the 25% and 50% buttons left to program in, and we're going to use an analog initialize to set the volume level to these values. And from looking at the panel, we know that the volume 25% is join number 10, and volume 50% is join number 11. And I don't need the ramp or the toggle anymore, so I'll get rid of those. Going to expand the number of inputs on the analog initialize with Alt+, and then I'll drag these volume percentages over to the initialize. And we know what the parameters should be pretty obvious, 25% and 50%. And again, we're going to take this analog output and jam it with what we already have from the slider and the ramp. You probably noticed that the volume 25% and volume 50% buttons don't have any feedback going to them, and neither does the mute button. Let's take care of that right now. So we want the mute button to have its feedback come from the output of the toggle, and then the volume 25 and 50% are going to be a little bit strange, but bear with me. We're going to add an analog div mod and an analog equate. And what the analog div mod is going to do is take the volume level as its input, and it's going to convert it from percentages to decimal. And what we're interested in is the quotient. The remainder we're just going to comment out. And now we're going to take the output of the analog div mod, and we're going to bring that over to our analog equate. And the equate's just going to tell us when the volume level hits 25 and 50%. So we're going to add one more output to it. And since we converted from percent to decimal, we're going to be looking for values of 25D and 50D. And these are going to provide our feedback for the 25 and 50% buttons. So the first one we're going to call volume level 25%, and the second one is volume level 50%. So then we'll just select both of these and then click and drag them over to feedbacks 10 and 11 on the X panel. So that looks pretty good with everything we have so far. Let's compile and upload and see how it looks. So immediately you'll notice that none of our buttons are visible, and that's because we forgot to add our visibility join, which is 12, which is shown here when the joins flash. But on the upside, the mute button works, so that's good. And what we're going to do is make these controls visible only when the volume is unmuted. So if we go back to our program, we're going to add an output to the toggle, call it volume unmuted. and then this is going to drive join 12 on our X panel. So when we look at the panel again, now all of our controls are visible. So let's make sure that everything works. When I drag the slider, we see that the volume level goes to exactly where the mouse is. If I get it right at 50%, we see the 50% mark light up, and if I get it down to 25%, let's see here, the 25% button lights up. And I can use these to set the volume manually to 25 and 50%. The down and the up arrows work. And mute also works. So this is good, but we can still make it a little bit better. The controls right now are really kind of jumpy. If you look at when we hit the 25% button, it just kind of jumps down to where it needs to be. But what we want it to do is kind of ramp smoothly to the value that we want. And luckily we can do this with the introduction of just one symbol. So back in our program, we're going to add an analog rate limiter. And let me just clear up the workspace. And the rate limiter is going to take our jammed output, the one that we've been using this entire time, and it's going to smooth out the way that the volume level changes. And the smoothed out volume is what we're going to use for our feedback on the panel, as well as the audio level being sent to the RMC. So let's see how that looks. When we interact with the slider, the first thing that we notice is that it takes a little bit of time for the bar on the slider to catch up with where the mouse is, which is good because it means that the change isn't as abrupt as it used to be. And we can further see this when we hit the 25% or the 50% buttons. It takes some time to ramp up to the value that we want it to be. And then even though we can't see it, when we hit the mute button, that volume level is slowly ramping down to 0%, and then when we unmute, it slowly ramps back up to whatever it was beforehand. And with that final change, we are done with the program. Remember that the source code is available for download at the link below, and if you have any questions, comments, or concerns, please leave them in the comments section. We look forward to reading them. Alright, well that wraps it up for this video. Thank you everyone for watching, liking, and subscribing.